Welcome everyone, thanks for coming down tonight. There's a lot of familiar faces in the crowd, but if you haven't been here before, the bathrooms are located just diagonally over that way. There's food and drink here, so help yourself throughout the talk, no problems getting up to keep the party going. Christian, our lead organiser, couldn't be here tonight. He's done himself a bit of an injury, so you'll have to put up with me as MC for the next 5 seconds. Tonight, very lucky to have Will here. Will's a specialist solutions architect in the Worldwide Services Organisation. A bit of a mouthful, but I think it means that he gets to work on some pretty cool stuff, including some open source projects and sustainability initiatives and other things. And very lucky to have Will down to talk to us about DynamoDB tonight. So look forward to a service deep dive from Will.
Thank you.
Thank you.
Jen, can you hear me? Yep, cool, thank you. All right, so my name is Will Sia. I work for an organization in the AWS called the WWSO cross industry. So I work with domain SA in 4 domains: sustainability, agriculture, aerospace, and chip manufacturing. So what I did is whenever they find a repeatable pattern, they come to our team and we build an open source based on that one, right? So today I'm gonna just talk about how do you do modeling in DynamoDB. So I was hoping for a lot of people that haven't been using a DynamoDB, but looks like got a lot of expert here. So hopefully it's not too boring for you. All right. So it's just a couple of page for marketing. What if I told you that your database can scale seamlessly by default, right? So the DynamoDB that you provision, that you created, the table, it's the same one that we created for Atlassian, the same one that we created for Samsung, right? So you get scalability by default, and it can support future use case without a lot of redesign, right? Which we're gonna see later on how you're gonna do that. And lastly, is a complex relationship can be modeled in DynamoDB. All right, just a quick overview of the agenda. So first, how do we do data modeling in DynamoDB? And then we're going to start with a bunch of the key DynamoDB concept, right? So we have something that we agree on in terms of term and everything. And then we pick a sample use case review where we can apply some of this concept into like a scenario, and then look at the different table design option as a foundation, a single table or multiple table. And then what do we put on top of that one, right? The schema building blocks. And at the end, we just bring it all together and see, and then you can try to do it on your own applications. All right. So in DynamoDB, we don't deal with cluster. Yeah, we don't deal with server maintenance. We don't deal with database versioning, right? So the highest abstraction is table, right? So when you create a resource, you create a table. Table is just a nice box where you can put an items, basically, right? And an items, it required first it require a partition key, right? This is going to be used by DynamoDB to get your item and then put that into like a massive partition that we created on behalf of you, right? And then you have the optional sort key. This is optional, right? If you only specify partition key, then you use DynamoDB as a key value table. But sort key is where do you put your item within that particular partition, right? So that allow you to either selectively select an item from that particular partition or select item within a particular range that you specify. But one thing that is important here is that you can have an arbitrary number of attributes aside from the partition and sort key, right? So you can pretty much store different type of entities into the same table. Right? The one that we really enforce is the partition key and this optional sort key. And that means that you don't have to store the attributes as a null or store attributes as a 0, for example, right? You can just not include that particular attributes. Right? Okay. And the other concept that we want to talk about is the global secondary index, right? So this is another table that is derived from this main table that we create and handle for your case, right? And stuff that we can do with the GSI table, as the first example is we can swap. You can swap the key that you use in your table, right? So that's give you like many-to-many relationship, right? Because when you access the table, you have a different type of a persona that want to look at the table, right? I as a user, for example, on an e-commerce company, I want to look at all of the orders that I purchase. But as a e-commerce company, I want to look at all the orders that I need to fulfill, right? So GSI give you the way to switch that particular persona, right? So that's the first example, right? The partition key and the sort key in the table, we just swap it around, right? So we have a many-to-many relationship. But with the GSI, the other thing that you can do is you can include some of the attributes from the table so that you're not wasting resources. You don't have to store all of the attributes from the main table. You can just selectively select some of the attribute that you want to project into GSI. And lastly, you can include all the attributes if you want to, right? If you want to do something with the other attributes. Okay, so use case, we want to build an e-commerce company, right? And to be able to build an informed data model, this is some of the stuff that you need to do, right? First is you just want to list all of the entities that you want to store in your table, right? Even though you're not doing relationship database design, you still have to list that entities, right? And then you have to, this is probably one of the most important things that I want to stress tonight, is that you have to list all of the access patterns that you want to do, right? The number of read and write that you do. Typically, this will be driven by your API itself, right? If you do your development using an API first, this is going to drive all of the access pattern to your data store. And then at the end, you want to look at all of the entities and then do a approximation in terms of the size of the entity, the cardinality, how unique are they, and the throughput, how often this particular entity is being accessed. All right. So just a sample entity that we're going to use in our use case. We have a customer, and we want to connect customer to the product that we're selling. And we connect them by customer adding stuff into the cart and hopefully placing an order based on active items into the cart. Yeah? All right. So some of the access pattern that we want to look at, customers should be able to add products to their shopping carts. Customers should be able to save an item in the cart for later, right? And then customers should be able to create an order based on the active items in their cart. And then after they're placing an order, they should be able to view the most recent order and the products, right? So that's the view from a customer point of view. But like I mentioned before, right? Typically in your database, you have a different persona trying to access the data from different point of view. So from a company point of view, from your company point of view, you want to be able to view all of the unfulfilled order, so we can look at all of those and start fulfilling the orders. And then you want to update the order items as you ship the order to the customer, basically. All right. So one of the things that we want to look at is that the cardinality of the data, right? How unique the data is, right? So if your company only sell one product, that means that your products have a low cardinality. If you sell 1 million products, you have a high cardinality, right? So in a real life, the customer cardinality will be quite high, right? So you would expect a lot of customer will be using your system. Product it's a medium size, and a shopping cart and orders typically follow the cardinality of customer. It's typically high, right? And the average size also quite varying. And the average size is quite important in DynamoDB case because of the pricing of DynamoDB, right? We don't charge based on your memory usage or CPU usage. We charge based on how many bytes that you read or write into the services. Yep. So if your entity size getting larger and larger, more than 400 KB, or even before that, you should look at splitting those into a logical split, basically. All right. So one of the first questions you ask yourself is that how should we organize the data to meet the needs of the application, right? Because this is one of the things that I want to stress is that for NoSQL database, we want to store the data as it's intended to be read. That's really important for optimizing, right? You store it the way you want the data to be read from the application, right? All right, so to build a schema design, you really need a very solid foundation. And one of the things that we get to normally ask is that single or multi-table design, right? The answer is, yeah, it depends, right? So in an actual use case, it's gonna vary, right? It's not gonna be single or one table per entity. And some of the things that you have to consider is one, the priority of your data, right? Do you have a different type of, you have workloads with different priority, right? If you have a table where you store an order, but you have another table that only being read every 2 weeks or every 3 weeks by the business analyst, then it makes sense to split those, because DynamoDB have an infrequent access table, right? If you combine all of those data into one table, then you will not get the discount that you get with an infrequent access table, right? And the other thing that you want to look at is when you go to like an Amazon web page, right? There is a bunch of entities that always query together, right? So when you look at the item, if they are always queried together, then maybe it makes sense to put them into the same table, right? The other thing is access control. If you have like an audit or like a security policy that prevent some type of data to be accessed by different application, then it's easier to secure if you separate them into a different table, because you can apply different IAM policy to make sure that a particular role or user cannot access this particular table. And lastly is the flexibility, right? If you put everything into one table and you have a downstream service that this table will send data to, DynamoDB streams or your DynamoDB backup, all of the data from that table will be either put into the stream or will be put into the backup. Do you really want it? If you have a restriction to ensure that this particular data cannot exist into the same backup, then it makes sense to split them into a different table. Multi-table, I think this is probably the one that makes a lot of sense for people that come from a relational database background, right? So you have one table per entity, right? So it's easier in terms of transferring all of the knowledge that you have been building, right, into the new domain. But one of the most painful thing is that if you want to query data that is the intersection between these two tables, now you have to do the join on the client side, right? Because DynamoDB does not allow you to do join, basically, right? But as I mentioned before, there are some benefit in terms of having like a multi-table design. Data isolation, right? You can have a primary key and sort key structure that is quite different depending on the entities. So we don't have to make sure that these different entities always mapped to the same primary key and sort key, right? They can have a different structure. Targeted access is the one that I mentioned before. The DynamoDB streams or the DynamoDB backup will contain only the data from the particular table. It will not be polluted for other data that you don't need. And then unique needs, again, you can have different backup patterns, different retention configuration, and different storage class, depending on the type of entity. And lastly, when you want to build something and you don't want to spend a lot of time learning, right? This is time to market. It's quite important. So probably makes sense in some of the cases where you want to just use a multi-table design. So the other is a single table design, right? So in this case, we have a single partition key or single entity that all of the data relates to, which is the user ID. And then the sort key is preloaded with a prefix to have a hierarchy built in the partition. Yep. So the sort key is a lexicography sort from left to right, right? So I don't know if you look at AWS ARN, right? You have the service name, account, region, and then the ID, right? It allow AWS to be able to give me all of the service based on the region and give me all of the service based on the account ID, region. Yeah, it's a similar idea here, right? I can have a user that have an address entity. I can have a user that has a different card. So you can actually build a hierarchy into your data over here. So some of the benefits, data locality. So related items now are stored in the same partition, right? Whenever you do a query, because if you do a query and then you have 4 items, but each of the item is a 1 kilobyte, for example, right? You will only pay for 1 read unit because we charge in the increment of 4 kilobyte. If you store it in 4 different tables and you do 4 different query, then we charge for 4 read unit. But if it's from 1 table and you're using query, you only pay for 1 RCU, basically, right? And balance usage. You have different entity with different access pattern, right? If you put everything in 1 table, the traffic will be smoothed out, basically, right? So you don't have to worry about whether you are under provision or over provision a particular table, because as you use a table, eventually it will balance out. Easier operations. You only have to do monitoring and alerting on a few tables rather than each of the table, right? That's operational that you don't have to do. And query optimization, which is related to data locality, it's a reduced RCU and latency because now you're only making 1 call and then you get all of data rather than 4 separate calls. Yep.
I'm not sure if it's the same pattern I've seen before, but one thing I can see is if you typically have like a couple of tables that have most of the data in one.
Yep.
If you're using that partition key to store essentially the identity of the table, you're not going to get use of that sharding to partition the data very cleanly, are you?
The partition key is the way we shard the data.
Yeah. If the partition key is the table identity, essentially what sort of record it is, whether it's a user ID or an order or a product.
Yep.
You're going to have a lot of entries all with the same partition key.
Which is fine, right? Yeah. So because each partition, I think at the moment is 10 gigabyte. So unless your user ID is more than that, then it.
What I've seen before where I have not laid out the indexes very well,
Mm-hmm.
and the throughput has suffered
Yep.
because the items haven't been spread nicely over the different partitions.
Yep. So I'll talk with you later and just look into more details what's the actual issue, right? So I mean, it may be that it depends how you do the partition. So I'm expecting that if you have 10,000 users and then you use the user ID as a partition, then the traffic will be spread into multiple partitions, right?
Oh, so correct me if I'm wrong, but
Yep.
the user ID, is that actually the user ID or is that literally USERID saying?
Oh, that's the user ID. So 1, 2, 3, 4. Yeah.
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 Identifying the table.
No, it's yeah. So so it's a UUID that's generated basically. Yeah. Okay. So now, just assume that we start with multi-table. We have 4 entities and then 4th table that we create, right, to start with. Now that you have this foundation, whether it's a multi and single table, right? Now it's we look at the building blocks, right? This is the bricks that we want to build our house with. Okay. And probably we mentioned this a lot of time. The most important thing here is the primary key and the short key. Yeah. So what happens when you select a partition key is DynamoDB will apply a one-way hash function that's going to determine which partition where we're going to put your item is, right? This is why very important where you choose a partition key that have a high cardinality to make sure that your data is spread around into this multiple partition. Yeah. So some of the guideline of choosing a partition key, the higher cardinality, the better, right? You don't want to choose a partition key where it's only a few type of it, right? And you want to start with an owner entity persona. If you even look at the relational database design, typically there's a table that every table connected to. Yeah, the one that you have like a foreign key from other table. So in an e-commerce company, that's typically the user ID, right? So I'm a user. I have my address detail. I have my order detail. I have my cart details, that kind of stuff, right? And then when you list your access pattern, your read and write access pattern, make sure that the key is used for most of the pattern rather than 2 or 3. Yeah. So user ID is probably a good one. So a quick quiz: who's think last name is a good partition key? Yeah. it's okay, but it's not really. Like Smith, for example, right, which is quite common. You have 5 or, I don't know, maybe 200 users with the same name, but because using their last name, they will be put in the same partition. Customer email, a bit better, but when the customer changes email, then you have to go through all the table, find the customer email, and make sure that that email gets changed, right? So UUID or GUR, anything that is uniquely generated, that's typically a good one, right? So whenever you use identity provider like Azure AD or Cognito, they typically assign you like a unique ID, and then you pretty much you can use that one to use it as a primary key. How about for a shopping cart entity, cart ID? Is that a good primary key? Yeah. Yes, but it's actually a trick question. You don't have a cart looking at the orders, right? You have a user who want to look at the order, right? So again, look at the persona. Who will access this particular data, this cart or this order, right? This is a user will typically access that one. So, all right. So we have our 4 entity with different primary key that we're going to use. Customer ID for product is product ID. Yep. Shopping cart and orders, we use the customer ID, right? So as you can see, the data, the bucket of data for a particular customer, like for me, for example, right? The bucket of data, my orders, my shopping carts, and my customer detail, now they will all be in the same partition, right? This is where I say the related items should be grouped together. So whenever you think of designing DynamoDB, think about the bucket of data that should go together. What if you want to model one-to-many relationship, right? So this is where sort key coming in, right? So it will group related items and then sort them under the same partition key. And then later on, we're going to build the sort key that can return multiple items at the same time. And it can be used to improve query performance, right? So now you have the capability to just, depending on the prefix that you put in a short key, to either return a particular item or return a range of items, for example, if you want to use like a epoch timestamp to list your, to store your order details, right? If I want to query my order from last week, I can just do where sort key between today and last week. And the access to a particular entity in the sort key is now split, yeah? So if you store everything into one item, and then the item is just keep on growing and growing, yeah, in the end, you either exceeds the DynamoDB item size, 400 kilobyte, or it's just going to be slower, right? Because you are moving a large chunks of data. And what we want to do is we don't want to design for unbounded growth. Yeah. One thing I mentioned is aside from UUID, there's a ULID that has a time component to the UUID. Yeah. So sometimes when you generate like an order ID, you have your primary key user ID, and then your S key is the order ID, for example, right? But UUID doesn't have a time component. You can use like ULID, which have time, right? So it gives you the sort by default. Just a quick illustration. I have put an order for number 1, and I do another order. It will go to the same partition, sorted by the order ID. This table looks like this. So now different customer will have different bucket of data that they will be interested in. All right. So what if you want to model hierarchical relationship? Yeah. So a lot of your entity will have different type of different status. Yeah. So your card will have an active, and we have a save for later one, right? So this is how we're going to use the prefix structure to be able to build this hierarchy. Yeah. So now if I want to look at all of the card that is active, for example, I can just do PK customer 123, and the SK begins with card active. And then if I want to look at a card that is safe, I can do PK custom 123 SK begin with card safe. But if you look at the Amazon website, when it load up with your details and the safe and then the active, right? So all of them will be retrieved together. Then what you can do is you can say begin with card, which is going to return you with all rows, right? And now marketing come and say, hey, I want to implement a wish list, right? So I want to, allow user to say, I have a wish list so other people can buy him a present. Then all you have to do to just add wish hash, right? So allow you to add a new feature without a major redesign, basically. Okay, so this is our schema progress so far. You have your shopping cart and orders, which the primary key is customer ID, and the short key is a cart hash status, and then the product SKU. And that SK is just some arbitrary things that you specify just to indicate that this particular row is like a root row. So if I want to get the customer detail, I can do PK equal customer ID and SK equal exclamation mark, for example, right? Similar with the product ID. All right. But engineering is not mainly about building a feature, but it's also a trade-off, yeah? I mentioned before, this is DynamoDB pricing. So whenever you do write, we charge you depending on how many bytes that you write, right? And it's in the increment of 1 kilobyte. So if you write 100 bytes, we will charge you 1 WCU. If you write 1 kilobyte, we will charge you WCU. 1,000 bytes, then it's 2 WCU. You just keep on incrementing. And the maximum number is 400 KB, yeah? So if you're storing item that is larger than that, then maybe don't use DynamoDB, right? We have S3 for that, right? You probably use DynamoDB as the metadata, but storing the actual content itself on S3. So somewhat trade-off. If you have 400 kilobytes of data, and then one of the issues that you might find if your data getting too big is that first, it increased the read of write costs, right? Because now you are reading and writing a large size of data. That's one thing. And the other thing is high latency because you are moving larger data around. And thirdly is you might encounter throttling because each partition at the moment, it allows you to do 1,000 WCU before it throttles your request. So if you write 3 items into the same partition and each of the item is 400 kilobytes, then you will exceed that maximum number of limit for a particular partition, then you might get throttled, right? So, and the reason why it's happening, whenever you do an update on item, what DynamoDB do is it look the item from the engine, right? Grab the whole item, applies the updates in the memory, and then write the item back to the engine. Yep. So if you update, so for example, if you keep all of your order lines on the same item, and you just update a status on one order, it doesn't really matter because you will grab the whole order lines, apply that one small changes, and writing it back, right? Your updates may be only, 1 kilobyte, but you will pay for 400 kilobyte, yeah? So that's the one that I mentioned before, right? So you store all of the order lines into one item. Whenever you do update, even though it's only a small, like the status for the particular order line, you will pay for the whole things. So your status update may be 20 bytes, but if the size item is 20 kilobyte, you pay for 20 WCU, all right? So what can you do to optimize the cost? I think vertical partitioning, right? So breaks the items into multiple lines, into multiple items. And how do you do it? One is the logical breaks, right? I think order lines is probably the one that is quite easy. So each of the order lines is a separate item that you can put on separate row. The other one is to see which part of the item is dynamic, which time is static, right? Dynamic means that you do quite update throughout the life cycle of your application. Then maybe you put that on a separate one, while the static one, you just separate those two. That way, whenever you do an update, you only do it on dynamic, and you don't have to pay for the penalty for the static entry. And the access frequency, right? What type of attribute that might, like I said, what type of attributes of your item that might get updated throughout the life cycle of the application. And lastly is the data integrity. This is the other way around, where you want to keep all of them together because you don't want to write it into like multiple line, and every time you do update, you have to do like a pagination to make sure that all of the items are updated all together, right? So in our case, now we separate those into a multiple line. Each line is a one-line item for a particular order. So now, if I want to update the status, I just have to select a particular row that I want to update. So I don't have to grab the whole order lines, basically. Yeah. And this is, but if I want to retrieve all the orders, all I have to do is where sk begin with order 1, right? Which should give you all the other orders. Right. So benefits of vertical partitioning: improve query performance, right? Because it reduces the cost of storing, updating large item, because you only work with the particular line of item that you want to update. And then you index the nested data. Now, if you want to get a particular order line for your order, you can get it rather than grabbing everything, right? Because of that sort key, you index the nested data, and it gives you fine-grained access control, right? If with the DynamoDB IAM policy, you can actually restrict a particular row, so to make sure that the particular row that begin with a particular prefix cannot be accessed. And scalability, right? Now that we are optimizing the schema that is for item that is going to be written more, then we're making sure that the database can scale. All right. So what is the trade-off, right? So if my whole item size is 50 WCU, right? And I separate those into 3, for example, right? I actually have to pay for, write is different with query. With query, it grab the item, combine the total size, and then charge you based on the total size. While with write, right, if you do like a batch write, we charge on each write, right? In this case, the total is 51 WCU, right? But if you do it in the entire item, what do you call this one? It's 51 WCU. Oh. Sorry. So the total is 50 WCU if you combine all of them together. But now, because we are splitting them into 3 items, the 500 bytes of the 2 items on the top is counted as 1 WCU, right? So in the end, you pay a bit more. You pay for 51 WCU, right? But remember, this is only the initial cost of setting up the item. Because as you use the application moving forward, you might be only updating the 1 item on the top, right? That means that on the long run, you actually pay cheaper, basically. All right. Now we have this particular schema. We have order lines entity, which is the prefix is order ID and the order line ID. Right. I think Jen's going to share it, but this is some of the other blog posts and slides that you can look later on. Some of the things that you can do to make it more efficient, like using a shorter name of attributes, for example, right? Yeah. All right. How can we filter data in DynamoDB? So 3 typical ways for you to do it. We talk about before filtering data using a partition sort key. And this is what you don't want to do, right? You don't want to filter with filter expression. What it will do a scan and grab the data and then perform a filter. So even though it only returns you a few items, you will be charged for the full scan, right? So what we really want to do is using a secondary index, right? Tonight we're just going to look at the GSI and not talk about local secondary index. So previously we looked at the point of view of the user, right? But now as a e-commerce company, how can I get a list of all orders that need to be charged and shipped, right? One thing I can do is to do scan with filter, which we want to avoid, where we scan the table and look at all of the items that hasn't been shipped. Yeah, that's we don't want to do. But what we want to do is to create a GSI that contain all of the orders that we need to ship, right? I think I explained before, GSI is just another table that is derived from the base table, right? It uses all of the change log from the base table to recreate the index, and then we maintain and update on your behalf, right? So in the new GSI, we're gonna introduce a new primary key and sort key, which is the order ID and the payment date, right? Now what I can do, every time I wanna look at all the orders that I need to fulfill, I just access the GSI and then start scanning it and then processing it one by one, basically, right? And then with GSI, you have a three-way you wanna project the data into the GSI. You can only project the keys only, and then you can include some of the attributes from the base table, right? But not all the attributes. Or lastly, you can include all of the attributes. Yeah, some of the benefits with GSI improve. The one that I want to highlight is a workload isolation, right? So if your base table are the one where people send a lot of data, right? While the GSIs might be used like not as often as the base table, but because they are two different tables, they both have different configuration and different limit, right? So whatever access pattern that user do on the GSI will not affect your base table because they are two separate resources as far as the DynamoDB concerned. And efficient data filtering. So this is probably related to the sparse index of the GSI. So just a quick one on this is the product index, which is another GSI that lists all of so previously we have a view from a customer, what product do I buy? Now with the GSI, I can flip the persona, right? Now I can see who's buying apples, who's buying oranges, right? Just by swapping the PK and SK from the base table to allow you to do that. Okay. Why it's important to choose the primary key of the index? Similar issue that we find with the base table, right? So GSI. So whenever you create a GSI, when you write a data into the table that is replicated to GSI, you have to pay both, right? You pay the write into the base table, but also the write to GSI, right? So it's additional cost and storage. And then if you don't choose the primary key properly, you have the same write contention that you have. And then consistency. GSI is eventually consistent, right? So it takes time, millisecond, before that they get replicated. And then management, you have to create and maintain and update your indexes.
Sorry.
Yeah.
Is the GSI write asynchronous? So whilst the base table
Yep.
goes back completes and then has an async action?
Yeah. So I'll send you a link to YouTube channel, but what happened you can see is as you write to the base table, there's like a commit logs that DynamoDB maintain, and that's the one that gets streamed, and then there's a process behind the scene that actually create a table based on that. So as asynchronous. Yep.
So with that last point with the management,
Yep.
you only mean the process of actually writing the code to create the secondary index. There's no
It's
additional work afterwards to...
more about if you have a throughput issue, for example, if a particular index being hit quite often, right? You have to set up the CloudWatch alarm to send, and then you have to write a code. If you use a provision throughput app, you have to write their own stuff. Yeah, yeah. So, all right. sparse index, right? This is just a continuation from before. When you create a GSI, you can specify a primary, you can create a new primary key and sort key, right? But what's great about the GSI is that if you're not specifying both of those keys, so the data will not be replicated to the GSI, yeah? So I repeat, right? You specify a primary key and a new primary key and sort key on your new GSI. If those two value, one of those two value doesn't exist when you write to the main table, those will not be replicated into the new GSI. So what you will have is a sparse index if you use it properly. Yeah. So what does it mean? Mean that if you set the payment date, every time a user create an order, you set the payment date. But every time you fulfill an order, you just remove that payment date from the attributes. And if payment date is the sort key of your GSI, when you remove that, then that data will not be available. It will be removed from GSI. That means that the GSI will have less and less data as you fulfill the order, basically, right? That's a sparse index, basically. All right. That's pretty much how you do. Set status to ship and just remove the payment date. Right? So, yep, just a recap. I think it's almost there. You model your data in a way that is efficient for your query pattern, right? So you want to save the data, how it's going to be queried, and no one size fits all. It varies by data and query pattern. And good partition key, that's really important. It's distribute data and reduce hotspot. And then you want to look at the size of your entity so that you can see how you best structure it so they can reduce costs. And then you want to use GSI to improve query performance, right? So, she's 4 resources that I highly recommended. One is the one by Alex Debris, right? It is into more detail in terms of using condition expression and all that kind of stuff, right? So quite a good follow-up from this one. And this one is when you want to use on-demand provision throughput or that kind of stuff. It's like an internal of a DynamoDB. And for a book, if you don't want to watch the video, Alex Debris have this book, which is quite good. And this is the one that got released a couple of months ago, written by one of the specialist SA in DynamoDB, right? So deep dive into more detail of this. So what I'm mentioned here is just a modeling bit of DynamoDB, right? But it has a lot of other features that I don't even mention, like DynamoDB streams, and then all the kind of stuff. That's all I have for today. Thank you.
I took a few questions all the way, but if there's any more, it'd be great to hear.
I think, sorry to go back so far, but
Yep.
I think it's the second slide where you have the primary key and attributes diagram.
Yep. Second slides.
One of those rows had just a primary key and a sort key with 0 attributes.
This one?
Yeah, like
Yep.
the second row down.
Yep.
What's an example, and sorry if this is more of a database question than a Dynamo question, but
Yep.
what would be a use case for that sort of second row?
It's typically a reverse index, right? So you store all the attributes on the main table, but sometimes when you do a query, you only have the ID from what do you call it, from the sort key A1. So typically what you do is you do where primary key equal that's probably a wrong one. So when you do a query on a GSI, you do primary key equal A2. It will get you a list of row, and you use that and then do a batch get on the main table. Yeah. And that's for the operation that you don't do quite often, right? This is why you don't replicate the whole data. But every now and then, you only have the sort key information, but not the primary key. So what you do is you get all of the details using the sort key. You get all of the ID, right? The combination ID, and then you do batch get from the main table.
So that's showing the query structure, not the data structure. So you wouldn't have like a
Yeah, yeah, that's right. Basically, if the information I only have is the sort key from the primary table, and every now and then I need to get all of the information that belong to the particular sort key, then I use that one to get all of the rows. Yeah, yeah, yeah. Yep.
Yep. One of the biggest pains with DynamoDB for myself is that you need to know the access patterns before you do one of these nice single table designs.
Yep.
And I have found the GSIs to be useful when I need to add those additional patterns, but I find you run out of them very quickly.
Run out the GSI?
Yeah.
Yeah.
And when you build in a brand new application, you never know what the users are going to do or what the product owner wants to come back with and say, I want this view on my dashboard. And you're like, now I'm going to do a database migration because this view is going to absolutely thrash the DB.
Yep.
Do you find going back to the typical, like that generic multi-table design for those sorts of fairly new products that haven't got a clear vision yet?
One thing that we do is try to keep the primary key attributes and sort key generic, right? So don't use user ID as the name, right? Yes, PK and SK. So I have a table that have PK and SK, and then let's say GSI1, I have a table that have PK and SKI1. And that way you can use the same table or the same index for different purposes. As you find more new use case, right, you can actually use the same structure, but just store different type of data. Yeah.
Some of the ones like, I want the last 5 transactions and you do a reverse sort on the sort key.
Yep.
Some of those, you just run out of your GSIs and secondary keys. So,
yep.
Yeah, that's what I found.
I mean, without going into details, it's hard to know, but yeah, I mean, keeping that generic at least allow that key to be used for more than one use case, right? Because now you're not trying to use your particular entity identifier on that one. You can use it for other stuff, and then.
Filters, or you get good larger query sizes because you can't go as fine-grained and get the exact data you want out of it.
Yeah, I mean, happy to delve into the actual detail here, but also don't forget about batch get and then that kind of stuff, right? That also help. Yeah.
I think it was a video as part of reInvent from last year that I watched on Dynamo. The guy there was saying that people were saying a similar thing, and so he'd sit with them and then kind of help them remodel it. And often he was able to consolidate down to a couple of GSIs, but you look at what they're doing to do that, and it's like some crazy gymnastics of overloading like all of the fields, like as we were saying, keep them generic. So it's like in the context of this type of row, it looks like this, but in the context of the next row, it's all just shifting around. So
I mean,
the database migration to go to the new sort of vision.
Yeah. I mean, I love DynamoDB, right? But it's not a silver bullet. Things like aggregation, for example. Yep. You cannot really do aggregation where you want to do a average on a particular entities, that kind of stuff.
Still use it in like greenfield projects where it's not clear because it's so cheap.
Yep. Yeah. But all the one that I see running in production with large scale, it is very hard to look at if you look at the console, you don't be able to understand it because it is optimized for the application code. Yeah. So to do a lot of overloading basically. Yeah.
I guess coming back to the GSIs, a common issue I've had before is user ID and an email, because email's unique.
Yep.
And a typical case is user sign up. You want to check to see if it exists in your table first before you go ahead and create a new user.
Yep.
So you've got to create a GSI on the email. And only this last year. So is there no way to create a unique key on something, on an attribute rather than a partition and a sort key?
You mean like in SQL where you just want to generate unique ID?
Yeah. The typical one you can just try and do a create as an duplicate field. I mean, I use Mongo a lot, so that's kind of where I'm kind of coming from. But I found that was a typical use case where it's like, I don't know, I don't have a user ID, so I can't use a partition key effectively to find this, so I have to use a GSI for this.
Yep.
But even then I'm paying for extra rights to try and like use a GSI to fetch it doesn't exist.
Let me understand the problem. Is it to generate a user ID that hasn't exist? Is that the issue, or?
It's more like just checking if it exists.
Yeah.
Because you're paying for reads to check if it exists, and then it's more of the case of you could then just throttle it as well. You could click up, sign up a few times, and you could actually get a couple in there because the username isn't unique yet because it's an asynchronous operation that will fail later.
Yeah. Well, with the asynchronous, you can have like a consistent rate, right, which you pay twice. Right? Yeah, that's the way to do it. But with user ID, I don't know. So this is mainly to ensure that this particular user haven't registered, right?
Satisfying a uniqueness constraint.
Okay, yeah.
Email address.
Yeah.
Yeah, the email address hasn't been seen before and should be able to be.
Yep. I thought that the condition expression does that for you. When you put, and then you have a condition that only when it doesn't exist, and that will throw exception.
Okay.
Yeah.
Yeah, but then
You don't have the right to do the uniqueness expression because you'll generate a new one and it'll be a brand new ID.
yeah.
That's based on the attribute, right? The email. So you wanna fail when this particular email exists, right?
Yeah.
Yeah.
The email is an attribute, right?
Yeah.
So it's an attribute on the partition key of the customer or the user ID or the customer ID.
Yeah.
Because they haven't created a GSI for that particular email yet. So
Yeah.
If you don't use a GSI, you can use the secondary index and make it consistent, but you need to set that up when you create the table.
Yeah,
Create a
I
brand new
didn't
table.
want to like put their email as a sort key or something.
Yeah.
Just going to say, the other thing that you can make use of is the time to live. So there's some things that you store in tables that you don't need to keep forever. So if you have like an attribute like a email sign up, and then the pseudo unique identifier like an email address, when you set a time to live, and it expires if it's not updated or something like that. So that you keep the data set small, and it's not necessarily converted to a full user ID yet.
But pretty sure I solved this with conditional expression before, but I'll check with this here. Yeah. Yeah.
Yeah, I was just going to ask, do you have any advice on tooling, like an ORM or a framework or something that you use with Dynamo?
I don't use any tooling, but heard a lot of good thing of DynamoBase, if I'm not mistaken. Yeah. But DynamoDB Workbench, right? I think they have that one. It's probably not a bad one, but I personally don't use it. Yeah. But
DynamoDB toolbox for TypeScript.
yeah.
Yeah, toolbox.
But one thing is, if you use PartiQL, be careful, right? Just in here, right? If you use the DynamoDB, the API, you kind of have to work with the abstraction, right? It doesn't hide behind, it doesn't try to abstract it. But with PartiQL, because it's a SQL, right? Sometimes you do something and it works, but it works with a small amount of data. Actually doing a scan behind the scene, for example, right? So just be careful when you use like a PartiQL, for example. Even though it's easy, but if you don't know how it's get translated into the actual DynamoDB API, that can generate like a inefficient call. Yeah.
The solution is to actually use prefixes on your partition key. So new UID with it once you've got that person registered, but then have email prefix and their email address there, so you can find if a unique record already exists just by using a partition key and just using prefixes on the actual keys themselves.
You come back to the original problem that you have to rewrite the entire partition when they change their email.
All you're doing is you're saying, because I thought it was a registration process, isn't it? So you go through a registration process, you submit your email address, create a record with a partition key with email address, and then you know that's there, so no one else could use that email address. And once they complete that process, then you can just delete that record and replace it with a UID record for the user ID.
It's like, so say someone sends an email one, and you want to change my email address, but still be able to view my previous audit history and other attributes that I've written on the table, and your login information is part of the
So that's a registration process, so a very temporal thing. And then you replace it with a primary key, which is the UID for that that user.
Yeah,
And then within that record, where you've got the UID, you actually have a column, an attribute called A4, like up there, which is their email address, which you can then modify as they need to as time goes by.
it's like a yeah, that's right. It's essentially like a lock, right? And then you can always create 2 rows. And next time you create a user, you do a transaction, right? If one of those fail, then it fails, right? And when you try to create another row with a particular email that already exists, for example, then if it's already there, it fails, right? But then again, your issue is that you don't want to pay twice, right? Yeah.
That was the whole issue.
Yeah.
Like, how do I put a unique constraint on it without having to read and then check, and then that comes down the throttle a bit.
Yeah.
Yeah, I was going to say, you just use the email as the partition key and then have a separate property, just have a duplicated data. Like,
Yeah.
the partition key can be anything, right? So like, you can just use it and you can have the email one later. And, you know, the partition key is just a random string, really.
Yeah.
It doesn't matter what it is.
Yeah.
I mean, that might even be an example of that second one, right?
Oh, yeah.
Yeah.
You might just have a hash of the email and then the dates
Yeah.
that they signed up and somebody says it's a registration.
Yeah.
I think that's a good point. Is that one thing that I have to get used to it is duplication is not a bad thing in DynamoDB, right? Yeah.
That's where I was forever just trying to not do that.
Yeah.
It was like, no, you know, so I was trying to find workarounds when you could just accept that, because there's no data behind it. You know, you don't have any attributes, it's just like, it's a simple.
It's a bit of a paradigm shift. You sort of have to let go of some of the third normal things that you've done in relational databases when you're embracing this.
Yeah.
Something else you've got to remember, and they came across this problem where I am, is how much is your time worth? How much is your company paying you to try and solve a problem where if they actually worked out how much you'd save by solving that problem, it'd be minuscule. So, you know, I mean, it's a cop-out, but it's reality. Developers are the most expensive resource. So, you know, it's a trade-off.
Use RDS. Yeah.
I was thinking about, I've never used DynamoDB before, but I was thinking about SaaS application, how function key can be designed for tenant isolation and performance.
Yeah.
Yeah, I was thinking about that. DynamoDB is good for that.
Yeah.
So the question's about, just for everyone, about tenant isolation for SaaS solutions and stuff.
Yeah.
Wait.
Isolation and the performance, because there's always trade-off with PSI.
Yeah. Why don't have separate table? I mean, in terms of cost, right? It's not really a...
But separate table is the system and the stack table is so much complex.
Yeah.
Because when you design a SaaS application, you have to have a table, a catalog table for indexing the tenant.
Yep.
From there, you isolate the tenant to boost the performance.
Yep.
Deliver the data to the particular client.
Yep.
But I was thinking to use the DynamoDB.
Yeah.
How?
I think Chris did a talk on SaaS, right? But you separate the data for your control plane and then your data plane for different tenant. Obviously, it's we need to know what you want to store, right, for your SaaS application, right? So DynamoDB does have like a yeah. No, I mean, but in terms of each row, you know what kind of how do you want to partition, right? You can use the tenant ID as a primary key, right? And then have like an IAM policy that say that for a particular a Lambda role that runs for a particular tenant will assume with a particular tags, and that will only allow him to access a row that is within a particular prefix. So that one way to guarantee that when my Lambda running on a particular tenant context can only access a particular row on DynamoDB. That's one way, right? But when it's become complicated, then it probably makes sense to have like a separate table on different tenant. Yeah. So yeah.
It will be very complex to maintain.
Yeah. Well, modern DynamoDB is like raising children, right? I'll get it right on my 4th time. If it, it takes time to get used to it. Yeah. Yeah.
It depends what kind of isolation that is be at an AWS
Just
account
AWS
level,
account
could be
level.
Dynamo table level, could be Dynamo table.
Yeah.
All those could be valid given the context.
I think Paul earlier mentioned is a preview feature, is an attribute-based control, which allow your data table now being tagged and then allow IAM to use the tag information to grant access to a particular table, right? So that's quite good in a SaaS application where you create a bunch of table for a particular tenant and tag it properly. And the IAM role running under particular context can only access that tenant, the table that is with the particular tag. Yeah. But probably need whiteboard next time to be able to design that. Yeah.
So DynamoDB is much less expensive than RDS.
It's yes. It depends, yeah. Yeah, but it's one thing. It's a serverless, right? I mean, one of the truly serverless nature. If you basically you only pay for what you use, you don't have like a up running cost, right? So yeah, I would say.
So it would justify like.
Not like those Aurora serverless.
Yeah, but that takes time to warm up. But
Compared to Aurora, it's the same pricing.
it's kind of hard because if you do a lot of aggregation, right? For example, you have a lot of data and then you do need to show the aggregate information. If I have to do it in DynamoDB, they have to put Kinesis stream or Kinesis data analytics that do like a select query to create that. In the end, might be more expensive, might be cheaper, like doing a serverless RDS. So, I mean, in general, for a lot of application where you don't really need the RDS, it's a lot cheaper. But there are some cases that it doesn't handle by itself, right? Because it's not meant to do that, then it might be cheaper to use RDS.
Cheaper is not probably the primary driver in most cases.
Yeah,
It's the
use case, yeah.
consistency of query
Yeah.
performance,
Mm.
which if you design your table right, shouldn't really vary much at all.
Yeah.
Always like single digit milliseconds.
If you design the partition key correctly, sub-millisecond, guaranteed, yeah.
If you've got a vast amount of data, if you run an SQL query, you've got an ADS instance, you're paying for the ADS instance, and you're really paying a lot for the query. Whereas if you've got a much amount of data and you accidentally, and I haven't yet, but it's always my view with serverless, like running too many lambdas or quickly running the wrong query with a very big data set, then you can end up paying a lot of money, right?
Yeah, if the PK is not, yeah, you do scan a lot of times, yeah, exactly. Yeah, this is why the modeling bit is the lot important, right? So you cannot use the same mindset that you used before, because now you want to massage the data and store it in a way that it's easier to query. So that's the key here, right? Yeah.
Limits or alerting on scan sizes? You can alert when you scan more than X number.
You mean after?
Or at least have some.
Definitely capacity. Yeah.
Yeah.
Just for, so you get an alert to like you want to refactor some sort of sort key or whatnot. You've got a dashboard that shows you that most of your queries are returning small subsets for one piece.
Yeah, I mean, you can wait until it hits the limit and you get throttled, or you can do scan with pagination, right? When the pagination number, I don't know, use what do you call it, X-ray, right? When it reaches a particular number of pagination, send a matrix, and then you just monitor matrix. So if I paginate quite a lot, and whenever I do a scan, that means that it's not, I'm not designing it properly. Yeah.
Thanks, Will.
Thank you. Yes.